Hello, let's do checkpoint 3.17. In this checkpoint, they want us to look at Titan, the largest moon of Saturn, which has a mass of 1.35 times 10 to the 23rd kilograms. And then the mass of Saturn is 5.68 times 10 to the 26 kilograms. And then it says Titan takes approximately 16 days to orbit the Sun. And they want us to use this information along with the universal gravitational constant. G is equal to 6.67 times 10 to the negative 11th. This should be meters cubed per kilograms times seconds squared. So we need to use a formula, and the formula that we'll use kind of looks like this. P is the period that it takes for a mass to go around another mass, a bigger mass, to orbit something. So this is the moon going around Saturn, and this is supposed to be equal to 4 pi squared times a cubed, and we want to divide that by the gravitation constant, and then the sum of the two masses. So this is our formula that we're going to use. Now we just have to be careful with units and to just identify the units carefully. Again, this is P in seconds squared. So that's seconds squared. That's going to cancel with the seconds squareds for the gravitation. 4 pi squared are just numbers. Now A is going to be the distance, and so let's put this in. It looks like the gravitational constant is with respect to meters, so this is meters cubed, and we have the gravitational constant, which is in meters cubed per kilogram times second squared. So the second squared again cancels with that. And then we have the mass, and each of these masses are in kilograms. And so when we add the two masses in kilograms, it's still going to be in kilograms. And so the kilograms would cancel. Kilograms would cancel with these kilograms. The second squared would cancel with the second squareds. And then we have the mass in cubes. And then we'll be looking for A in this case. All right, so the units all worked out. And we just have to worry about transforming some of the things into units. Okay, now that we have some of that identified, let's figure out what P is. So P is going to be in 16 days. But remember, we want this in seconds. So there are 24 hours per day, and there are 60 minutes in an hour and 60 seconds in a minute. So that would be 60 squared, or 3,600 seconds per hour. So whatever this number is going to be our P. Our G is the gravitational constant. It's already given. Let's just rewrite it. G is equal to 6.67 times 10 to the negative 11th power. And the units are already taken care of, so let's not worry about the units. The little mass for Titan is 1.35 times 10 to the 23rd kilograms. The big mass for Saturn is 5.68 times 10 to the 26th kilograms. And I think that's it. And then we just need to worry about pi and all that stuff. So what we'll do is we're going to punch all this stuff in the calculator, but we're solving for A. And if we're solving for A here, then it looks like we're just multiplying by, let's say, a cubed is going to be p squared times the gravitational constant times the sum of the masses divided by 4 pi squared. And then we just take the cube root of that, and that should give us a. All right, let's get to it. For a graphing calculator like the TI-84, I think it might be good to get yourself set up in scientific notation. So if you hit mode and instead of normal, go to scientific notation. And then if you're not specific about your accuracy and how many decimal places you want, and you just leave it as float, then it'll take care of itself. All right, so let's get out of here and go back to the main screen. And let's start with the P. We had 16 days. So we'll have 16 days, and we're going to multiply that with 24 for the 24 hours per day. And then 60 times 60, we're going to multiply that by 3,600. And then we'll get, this is how many seconds, 1.38 million seconds in 16 days. We want to square that. So that gives p squared. And then we're going to multiply it by g times m plus m. So let's go ahead and multiply that times the gravitational constant. That's 6.67. And I'm going to use this notation. This second function and the comma gives you the e notation, which means it's going to be an exponential or scientific notation. And we just put the power, which is -11, and that gives us our gravitational constant. And then we're going to multiply this by little m, and little m was 1.35. And then again times 10 to the 23rd. And then inside of the parentheses, we're adding the mass of Saturn, which is 5.68. And that is going to 10 to the 26th power. And we'll close the parentheses and get our value. So this is the numerator. Let's get some of these, let's save some of this stuff for our notes. And then this gives us some idea of what's there, what we've done so far. Okay, so now we have the whole numerator. We want to divide by 4 pi squared. So I'll hit divide and then 4. Now you have to be careful. If you put divide by 4 and then pi squared, it's going to think you're just going to divide by 4 and then you're going to multiply it by pi squared. So you want the whole thing in the denominator. I would put parentheses around there. And then let's look for pi to the second power. Close the parentheses, and that would give us a cubed. So this is a cubed, and we want to take the cube root of this. So we'll take this value, we'll take the answer, and we'll raise this to the 1/3 power. So the power needs parentheses because it's a fraction. 1 divided by 3. We'll close that. And then we get this. So this should be the result that we're looking for. And it looks like it's 1.2 times 10 to the 9th. So that goes into billions. We're looking at this thing going, this thing going in the billions. And remember that this is in meters. So 1.224132319 times 10 to the 9th power. Now it's in meters, so probably if we multiply it times and put it in kilometers, multiply it by 1,000, and we get to move the decimal place 3 times, and that's just, oops, I should have said divide by 1,000. So let's try that again. Nope, let's just take this and let's divide by 1,000 and another 1,000. There we go. So this is in meters. And of course, if you multiply this by or divide by 1,000, you're going to lose 3 decimal places. So this is 1.221132319 times 10 to the 6, and now we can express this in kilometers. Okay, we're looking at about 1.2 million kilometers. So that should be the answer. And just to be sure, I did check it in the website. If we double check this and see what the distance is from Saturn to Titan. Now the distance is probably going to be changing, varying, because it's not going around in a perfect circle. It's elliptical, but it's close enough. And here they say the distance is about 759,000 miles, which is equivalent to 1.2 million kilometers, which is what we got. Okay. All right. I hope that helps, and good luck with your work.